So let's take a moment here. I think we're in good shape. Let me see. There's a little bit of buffering, but let me see. We're in good shape. Ready to go. Okay. I wasn't sure about when I should start streaming, so I just kind of turned the stream on and started. I think it's all right. Let me go ahead and continue. So we'll get right into it. This question, my solution is maybe not the best, so we'll come back to that later. It's kind of involved, and then this solution, I'm going to skip this one for now because I thought of an idea and I was like, it's kind of complicated and I don't really want to program it. And I was like, I should just program something, just do something productive instead of nothing. So I was like, all right, I'll just get on stream and do a couple hours of some other stuff. It'll be all right. Given a string S, reorder the string using the following algorithm. Remove the smallest character from S and append it to the result. The smallest character from S is greater than the last appended character to the result. Okay. Repeat step 2 until no more characters can be removed. Okay, I mean, that's basically sort it. You'll get a sorted list if you do it that way. Be the first, second, third, yeah. It's sorted in ascending order. Okay. Move the largest and append it to the result. Smaller than the last and append it to the result. Okay, and then this is now, if you keep doing that, it's going to be sorted in ascending, now it's going to be sorted in descending order. Descending order, okay. Repeat steps 1 through 6 until all characters from S have been removed. I'm really confused by what? Wait, what? Wait, what did they want? I'm very confused. Steps 1, 2, and 3. Huh? That's not, I mean, maybe I just misunderstand. So, oh, I guess it's got to be a different character than, oh, I see. Okay. I think I understand now. Okay, it's not. It's not just sorting it. Okay, got it. Got it. It's kind of subtle. Okay, I see now. So if they were distinct characters, it would be sorting it, but because they're not. Okay, so what this ends up being is basically use the frequency map, and you're gonna just basically work your way through the frequency map, back and forth, pretty much. Yeah, which is interesting. There are a few ways to do this. Simplest thing is, create the frequency map, and then, probably not the simplest, but one way is create a frequency map, then take the minimum value and do basically you have like a toggle. So you're gonna do a forward and a backwards. So take the minimum frequency, subtract that from all the frequency values, and then create, for all the frequencies that are not 0, create a forward pass string. So from smallest to largest, append that to the result. Then repeat that, but toggle going backwards. So you're going to take all the frequencies that are not 0, and if your minimum frequency is more than 1, then you're going to do a forward pass, backward pass repeated for each value, for each, like, whatever that number is. That's how many times you're going to do it. Quite frankly, it might be easier to just go back and forth through the frequency map, backwards, forwards. I think if there's an easier way to do this. Interesting question. I mean, it's only 500 characters, so most solutions should be 100%. I wonder. Thinking about it. Yeah, I mean, it's fine. I could just go forwards and backwards repeatedly. I think it's okay. Let's start with that. Int frequency. I think they're all lowercase characters. Check that now. The backwards forwards approach, I think, is just a lot simpler. So bool. Oh, actually, I have an idea. I have an idea. 0 j I is less than 26. We're going to do it like this. We're going to use a toggle. Actually, let's do, yeah, we could do it this way. We're not going to use the toggle. Keep this simple. So while, so I do a for loop. For count equals 0, count is less than size. And we're not going to increment the count. Now we're going to do, how about we implement it this way? So we're going to do int, I don't know, string result. We're going to say I is 0, 26, increment I. And say if frequency of I is 0, increment the count, and result plus equals A plus I. And then we go backwards the other way. From 25 greater than or equal to 0. Decrement I now. Oh, and something important, got a decrement frequency. This is maybe a better way to do it than what I was considering doing a moment ago. Let's try this. Let's try this. This might be it. Compiler. Okay. Solution. Okay, what did I do? Oh, it's the wrong spot. Okay, let's try that. That might be better. What is going on? What did I do? Oh, I did delete the thing. Okay, I don't know how I did that. I guess maybe it's because I used the like. Oh my gosh. Okay. So I had this right in the first place. I just somehow deleted one of these characters. Didn't realize I did that. Interesting. Okay. Um. Okay. I'm gonna go for it. I think this is correct. Yeah. Okay. All right. Yeah. 100%. It's fast. It's pretty good. Keep going. How do we do on time? 10 minutes, 11 minutes. Holy smokes. All right. This one I said I was gonna skip. I could close this. Okay. Given a string word, letter is called special if it appears both in lowercase and uppercase in the word. Turn the number of special letters in the word. Special if it appears both in lowercase and uppercase in word. Number of special characters. The number of special characters. Okay. Easy ways to use Boolean. I'm gonna use a bit mask. Long bit mask. We're gonna say up is upper, and then is lower. Star ch word is upper, or equals ch and 32 is greater than 0. So it's going to be so this is going to be is lower. Where it is ch and 32. Lower is upper. Not lower. And this is going to be bit shifted by ch minus a. Yeah, and then we're going to say for yes by 0. So let's I think 50. Oh, actually, you just do pop count. I don't know. Yeah, we do pop count. Forgot bit manipulation. Yeah, you could do built-in pop count of slower and is upper. Not and, it's and bitwise and. Yeah, that's probably a little bit better. I think that's what we're looking for here. Runtime error, of course. It's negative. Oh, that's subtle. Okay. Right. So, or 32, I forgot. It's a subtle thing. This'll, yeah, okay, it's pretty awkward. I'll explain in a minute what's going on there. There you go. So that's pretty straightforward. We're gonna say int or constant. Yeah. So this will convert to this will convert to get the character position by subtracting a. The thing that's tricky about it is if it's a lowercase character and I subtract lowercase a, it'll be correct. But if it's an uppercase character and I subtract lowercase a, it won't be correct. So that's why I had to OR it with 32 to ensure it's a lowercase character. This probably gets optimized anyway, but this should be about right. Probably should have used like position instead of bit here. Yeah, I like this approach. This is reasonable. This is pretty okay. Using a bit mask to store the which things are being set. That's cool. I like that. Let's see what else I can do here. Just give me 1 second. Just want to see. I think it's okay. Oh, whoops. Okay. All right. So, given a 0 index integer array nums and 2 integers key and k, a k distant index is an index I of nums for which there exists at least one index j such that the distance between I and j is less than or equal to k, and nums of j is equal to the key. Turn a list of all k distant indices sorted in increasing order. Okay, 0 indexed or integer array nums, 2 integers key and k. A k distant index is an index I of nums for which there exists at least one index j such that the difference between I and j is less than or equal to k, and nums of j is equal to key. Huh. Integer array nums, 2 integers key and k. K distant index. So nums of j is equal to the key, and it's no further than k elements away in both directions. Okay. So I have a key and k, and I've got to figure out how many indices, excuse me, aren't that far away that have this nums of j equals key. Well, I mean, basically, I can just take a look at the keys themselves, and to the left and to the right would be this range, this k range. And they might overlap, in which case I would just merge those overlapping intervals. So yeah, interesting. There's no overlap for the first key, but the second key might have some overlap. To check the overlap, all I need to do is check and see if to check the overlap, all I would need to do is check and see if the left side, which is going to be like position minus k, or excuse me, yeah, position minus k, There's position minus k and position plus k. Position k minus position minus k, or excuse me, position minus k is exactly k. It's less than or equal to k. Indices, so it's position minus k index and position plus k index. I think all I have to do really is just check the previous right bound. That's really all I need is the right bound. You can go left to right. Okay, I'll do it that way. All right. So before I equals 0, I is this nums dot size, I. This is pretty doable. This could be the size of nums. And then we'll return the result. Say if nums of I equals key. Also, we're going to start on this right side is 0. It's the previous right side. We're going to set this to, so if I minus k is greater than r, or is less than or equal to r. It's less than r. Then we're going to start also going to push back. Could just do a for loop, I guess. Try to decide if I want to I could use a back inserter with std iota, I think, which is cool. I should do that. Nums.begin plus r plus 1 to nums.begin plus I plus k. With a back inserter. And this should start off at whatever the previous value was. So back this one. Okay, this is a little awkward. A little awkward. Okay. That's if we are smaller than r, and by the way, we're going to set up r to be I plus k. Otherwise, we're going to std iota. Maybe I shouldn't use iota here, actually. So if I minus k is less than r, then we start r plus 1, because we already added r, we're going to r plus 1. If, on the other hand, if I minus k is further to the right of r, it's greater than or equal to r. Yeah, if it's a little confused, I think it's if it's less than or equal to r, because we don't include r. If it's greater than r, then we just start at r, or we start at that value, I minus k. Yeah, that works. Okay. Just take that whole range. I did this wrong, didn't I? I did. It's not nums.begin. It's like result back. Oh, it's confusing. Okay. Back inserter. Hold on. Let me ask. I'm gonna ask the AI about this. I'm pretty sure the AI knows. Did I forgot that's one of the things I forgot. Give me one moment here. Uno momento, por favor. Uno momento, por favor. Forgot a subtle thing. That's not that subtle. I like to have like an AI window ready so I can ask questions. I don't really trust most platforms though, so I have to use a specific one, I guess. And in theory, I'm working on a secure one that can be used, like basically a local one. But I have to be careful about that, though, because of complex reasons that I shouldn't share. All right. Off by one error. I shouldn't have just copy pasted. Actually, my question is that I want to back insert into the result starting from values 1 more last value. Is that reasonable? Yeah, this is a problem I've run into using the STL algorithms library, that like I try to like kind of force things a little bit, and I end up like taking a lot longer to write something than if I just used a raw loop. I would know immediately what to do. Yeah, so I'm not supposed to write the range of nums, reading the last value, not actually inserting anything to result in the step. Okay, that's fine. Result to result directly into result. Result.end. Okay. Okay, I don't want to write all the way into result. Just want to write a specific range of numbers. So if I use what they gave me, this is going to write all the way through. So I guess I don't need to use a back inserter. Also want to back insert. Okay. What did I say? Mistake. No. I made a small typo. Small typo. Enter nums. Should be more like result. I don't know how to even express this to the AI. I don't even know how to explain this. I think it'll figure it out, but it's. So, I need a back inserter. This is a bit confusing. Generate n. Okay. Count elements to resulting in it for starting from. It's cleaner and safer than trying to force std.io to work with an infinite output iterator. Okay. Generate n. Oh, it is gone. What is this? Lambda, immutable lambda. Oh boy. Okay. Interesting. Okay. Generate n, count number of elements to append. Huh. What does that lambda do? Doesn't trigger reallocations. Okay. I don't want to do it that way. I'm gonna try to generate. Is there maybe a better approach? Better approach than the mutable lambda. I mean, we could use that. That's pretty good. Okay, let's go back. So we're going to std generate n. I think it said result. So back inserter std back inserter result.end. And it's going to be count is I plus k minus r plus 1 plus 1. Excuse me. I minus k is less than or equal to r. Yeah, this is correct. Yeah. These cancel. This also isn't how many. This is the range. Oh, that's confusing. No, it is a nice R though. That's fine. Yeah, that's a little confusing. And then the lambda. This is very interesting. So they use plus plus val. With val equals. Salt that back, I think. To start. And then they said it's mutable. And that's about it. I don't know if this goes on the left or the right. I think it goes on the right side. That's pretty interesting. Let me see this. 3 cleaner approaches. Okay. Oh no, they put the mutable on the right side. Okay. And they did val plus plus, which actually plus plus val is fine here. What does mutable do? Right? Curious. It's inside. I should read the cleaner ones. I actually don't remember what the mutable thing does here. Okay. And this is going to be I plus k, I minus k, which is just exactly 2k plus 1, I think is what the AI figured out already. This works fine. I'm going to try this and see what happens. See if that even compiles. Oh. Without mutable. Oh, okay. Lambda's operator is more const. Oh, I see. Okay. So you can't do this without mutable in there. Oh, I see. Const qualifier from the lambda's operator, allowing it to modify its own internal copy of the captured variable. That's interesting. Only inside the lambda. It's very interesting. Okay. Compiler. Result end. All right. I'm gonna just dump this into the AI, see what it says. I don't know. I'm actually not sure what the back inserter should be. Maybe it's just result, actually. I think it's, I don't remember the syntax. I think it's just, I think it's actually just result. Also, I'm not sure if I can use this back here like this. I think that'll give me the wrong answer. Let's try this. I don't remember exactly the, yeah, like if I used a 3 critical bugs. Okay, great. I don't remember. Yeah, if I had just used a raw loop, this would have been done like quite a while ago. It's good to kind of practice and learn things. Pre-allocation, uh, temporary resize. I don't really like that one. Increment generator, small functor, struct. I don't really like that either. Functor struct is a little overkill. Views iota. Create the sequence lazily. Interesting. Start value count, insert, range begin, range end. Oh, that. Do like that. That's kind of cool. It's tempting to do that. 23, you can just do or equals. Or not or equals, but pipe in the iota and then pipe that to a vector. Oh, that's pretty interesting. I don't know. Okay. We're not using a functor struct. That's too much. I don't want to use a pre-allocated vector because I don't technically know the space, and I don't want to overshoot the space, although it doesn't really matter. Like I could do that too. It definitely makes things a little bit simpler. I kind of prefer this approach though. Type. Okay. Yeah, I think the result.back is wrong here. Oh, there's another error here. Shucks, both of these are wrong, actually. Const hints right bound. This has got to be stdmin of I plus k, and I think it's n minus 1, nums that size minus 1. Yeah, that's important. Bound needs to be in the right spot here. Yeah. And R gets updated to bound. So this is actually bound minus plus k minus I, I minus k. It's minus I plus k plus 1. That's confusing. That's very confusing. No. It's I minus k. Yeah, I minus k. Okay. Oh, okay. Oh boy. All right. This is a static cast as well, which is a little awkward because of the size. So I'm just gonna do this. I don't normally do this, but it works a little bit better in this case because of the static cast that I would put in here is too long. It's just too many characters for such a simple thing. Okay, buffer. All right. Interesting. I think it's because of this, maybe. Oh, this is. Oh yeah. So yeah. Hmm. Which one did this happen on? Buffer overflow. A little surprised by that. Okay. Hmm. Hmm. There's another error here. Lower bound. Yeah. Okay. That might be the issue. It's ended up being way more complicated than I thought it would be. A lot more effort. Okay. That could be the issue, is the lower bound. No, I don't need to do this actually. The lower bound. That's not necessary. If it's less than or equal to R, then we're going to process with R. If it's greater than or equal to R, then I don't need to check. Yeah, this actually is fine, I think this is okay. Like if it's if this was negative, then it would just use 0 for. So it's actually happening here, but the I mean, I could try to debug this. Okay. I don't know why it's giving me that. I don't know what the reason is. I guess I'll find out now. What's up? Grind. What's up? Grind. That is a scam. What's up, man? Are you using back insert or what is this even? Never seen such advanced code for an easy question. Yeah, it's I'm using the STL algorithms. So I use a back inserter for the vector. It'll automatically adjust the size of the vector if I need more space. Which, oh yeah. The reason why I wanted to do that is I didn't want to resize the vector at the end, which I could technically do that, but I didn't want to because I know there's a way to do it without doing that. Yeah, slight error here. Yeah, it's actually really simple code. So all it's doing is just because you asked what's going on with the code. So it's number 2200. Find all k distant indices in an array. I can read the question in a second, but the solution here is basically I just scan left to right, find where the numbers, where the key is in the array, and then I would say, okay, there's a range of numbers left and right that I need to put into my return vector. And so all I've got to do is just make sure I handle the edge cases when I'm close to the edge, and the cases where I have keys that are overlapping. And aside from those edge cases, the edges and the overlaps, I can just basically take that range around the key and dump it into my return vector. That's what the generate n is. It's just I'm not very familiar with this syntax, so I just don't know it offhand. So I kind of running into some minor issues here, or yeah, relatively minor issues. Doing some learning here. So bound is 3. I executed that once. It might be good. Excuse me, it might be good to get a little more information. I minus k plus 1. Yeah, I probably should print a little bit more there. But for some reason that gave me a runtime error, and it's not obvious as to why. I'm probably just running over the memory somewhere. I thought maybe this was the issue, but actually this just gives me a very large numbers potentially, not necessarily a memory issue. Depending on how this works. I think the binding for the lambda happens once here. I'm not entirely sure. Let's do that. Let's just get more information about what's going on. Probably don't need to know more than what I is. Maybe I would do want to know the bound. Yeah, I could have used a raw loop for this, but I kind of wanted to flex, not flex, but practice with practice with some of the STL algorithms and the syntax. All right, so 0, 1, 2. Okay, yeah, we're looking for 9. Bound is 3. Yeah, that would be on the right side. Let me say k is here. K is 1. Okay, so it should just be these 3 here. Yeah, the bound is exactly on the right side. And for some reason, I gotta know how bit buffer overflow. What's the error? Heap buffer overflow. Hmm. Huh. Get any more information? Probably not. Not really. Okay. Nothing odd. Nothing like really immediate obvious. I don't know why this is so immediately had an issue. I have a back inserter. It's 3 buffer overflow. Oh, that's subtle. Okay, I see. Okay. That's actually not that easy to. Okay, I know what to do. I know what to do. Okay. I didn't even think about that. Think about so many other things that I totally missed that. Yeah, you can't do result that back on an empty vector. That's kind of easy thing to spot. Yeah. Isn't really a start. Isn't exactly the start value, but it's close. Okay, so that's probably what went wrong. Okay, it's wrong in this case though. K is 2, K is 2. Output 0, 1, 2, 3, 4 should be 0. Oh, did I not? Oh, whoops. Oh yeah. Oh, okay. All right. It's really negative 1 then. Yeah, that's interesting. Okay. Yeah, because I insist on having a pre-increment, which may not be the best thing, but I think it's a little bit faster to use a pre-increment, so that's why. That may not be the best way to do it. I probably should use a post-increment, quite frankly, for the sake of oh, it's wrong now. Okay. Interesting. It's wrong here too. Oh, it's just logically incorrect now. I see. Let me use a post increment to make things a little more reasonable here, easier to grasp. And then I can look at why I'm. So I'm actually. I think the logic is technically wrong. There's something I'm missing here. Which it's probably just this is slightly off by 1 error. Also, what's up, chat? Oh yeah, I'll come back. I'll read chat. I'll read chat in a moment. Okay, so this has got 0, 1, 2, 2, 3, 4. Not quite right, but at least 6 elements. And the other one should just be 0, 1, 2, 3, 4. Oh, yeah, I did that wrong. Okay, it's supposed to, I should do a pre-increment because I'm starting from the back. I mean, I can start from the back plus 1. That works too. Or that's confusing. Oh man, that's confusing. This should be probably from the back plus 1. Let's try that again. Oh, still wrong. Its logic is slightly off. 0, 1, 2, 3, 4, 5. Expected 1, 2, 3, 4, 5, 6. So this is off by 1. And what about the other one? The other one, it's also wrong. 0, 1, I'm missing one value. Okay. Let's start with the first one. So 0, 1, 2, 3, 4, 5 is just plain wrong. Initially, I is 2, bound is 3. 2 plus 1 plus 1, okay. Zero, 1, 2. So it should add 1, 2, 3, and it should be the second piece of code here. And oh, that's pretty awkward. So this is slightly incorrect. It's not always going to be in the back. That's my mistake. Okay, I did that wrong. Yeah, I don't know what got into me, but I got that wrong. Okay, so in this case, start value is going to be, you can actually, I don't even need this. Or actually, I do. Yeah. Okay, no, I don't. All right. So if I minus k is less than or equal to r, we're going to start at r plus 1. If, on the other hand, I minus k is greater than r, then we start at minus k. And that is a little bit confusing. I kind of missed that before. Okay, I got the first one right now. Second one is a little off. Missing 0. And that might be because r should be really -1 initially if I'm going to do a plus 1 here. I don't know if this is totally correct, actually. It should maybe just be r. No, it's definitely r plus 1. If the other side, if I always add r in there, then yeah, which I do. So we'll just start with r minus 1. There we go. Okay, a bit subtle. It's a bit subtle. Let's tinker with this a bit more. So this ended up being way more complicated than it should have been, quite frankly. Let's add more things. Yeah, I don't know why this ended up being so much more difficult than it should have been. I think just my own tinkering. All right, let's try something like this. Also meant to reach out a while ago. I'm doing okay. I'm doing good. Have you been? Just started solving LeetCode this week. It's fun to find you. Gonna be a regular one. All the best. Cool. Yeah. Awesome. Yeah, LeetCode's a lot of fun, man. It's a lot of fun. A little more about this back insert thing. I'm surprised because LeetCode never ever requires such syntax. I wouldn't say it requires it. I mean, you could do all this with raw loops if you wanted to. When I'm stuck like this, I directly copy and paste to ChatGPT. What was the small annoying little mistake? Okay, keep it up. Yeah. I do. Yeah, I do just copy paste things. Although not always. Like sometimes I try to think about it. If it's something I don't immediately recognize, then I'll copy paste it and see what it says. So my code had a bunch of issues. So I'm not gonna. Oh, okay. In this case. I missed that somewhere in there. I had an extra. I was trying to avoid that, but I didn't catch it. Okay. Yeah. If I like don't know it immediately, then I'll post it. Oh, looks. All right, I'm gonna go for it. This may or may not be. There's a high chance that I have an edge case that I missed. I actually didn't think. Oh, it's good. Got it. Okay, got it. Yeah, that was like way more complicated than it should have been. Actually, a little more complicated. Oh, I didn't even realize I had this. Have the debug code in there. Yeah, this is okay. It's okay reasoning. I think I just got kind of hung up on the back inserter and the generate and all this stuff. And the lambda. Yeah, it's kind of just unfamiliar syntax to me. So it ended up being more complex than it needed to be. Excuse me, but not too bad. Worked out. It's pretty good. Give me one moment here. Just a moment. Okay. Let me submit it one more time. One more submission. Did I not? I might not have done the thing. Okay. Let's submit it one more time. So let me look at the next question. Ohio. What's up? Suda Karedi. What's up? There we go, 100%. Sweet. Howdy. How are we doing on time? It's already been an hour. Okay. I was gonna go for 2 hours today. So we got another hour. All right, here we go. Delete leaves with a given value. See, that question was not a hard question, but I kind of coded it in a way that took me a while. I don't know if that was the best way. I probably should use the raw loop, quite frankly. But that's okay. Delete leaves with a given value. Given a binary tree root and an integer target, delete all the leaf nodes with value equals target, value target. Note that once you delete a leaf node with value target, its parent node becomes a leaf node and has the value target. It should also be deleted. You need to continue doing that until you cannot. Oh, okay. Okay. This is more of a topological question than it is a. So really, I've got to start at the leaf nodes and work up towards the parent nodes. But it's a tree, so it's a little bit awkward. What I could do is I could do it recursively and say, okay, if the left subtree and the right subtree are either null point, or I'm going to delete them first. I could do a post-order traversal. So I do the left subtree, do the right subtree, and then at the root node, if the left subtree is a null pointer and the right subtree is a null pointer, I could use booleans, maybe it's better. So if I get a boolean true for the left side, set it to null pointer, delete the memory, free the memory. Same thing on the right side, free the memory. And then if they're both freed, then I'll return true for this node for the recursive case to delete it. Do you have to delete the root node though? Which I think the root node I'll just check in an if statement. That works. Post-order traversal seems okay here. Give it a shot. Try it. Okay, so we're gonna do const auto recurse. We're gonna use self. Self auto. Oh no, that's this. It's very specific syntax. And then we're going to say tree node. We're going to say if node not no pointers, we're going to return false. Actually, we're going to return true. Then we're going to say constable left equals self node left, and right, same thing. It's also kind of good to do this. Okay. So if we're gonna come back to we'll come back to this in a moment. It's going to be the root node. Yeah. Root. So I think this needs the target. Okay. Oh yeah. Or if node value. Oh, we'll come back to this too. And left and right. So if left node left, we're going to say delete node left. I think this works. This will free the memory on the left side. And this also frees the memory on the right side. It's appropriate to do so. And then so if recurse root, then we're going to delete the root too. Something like this. Let's see what happens. What's up, chat? Oh, okay. Oh, good. I think we got it. I'm going to go for it. I think it's probably correct. Oh, brutal. Absolutely brutal. Okay. Wrong. Target 1. What is it supposed to do in this test case? I probably should have just tried this test case. It's not a hard test case to think of. And you know what I should have done? I should have just read the example a little bit better. It's probably in the example somewhere. Doesn't say. Doesn't say. I got right to. What is the expectation here? Let me just return. It's not obvious what they want. Also interesting that let me just do this for now. Let's see what I'm not sure what the runtime error is. I'll have to figure that out. But what is this here? What are they expecting? Expected empty. Okay. Huh. I mean, is that just a null pointer? Excuse me. Oh, it is. Okay. So apparently I did something that's not obvious here. Yeah, I don't delete the node itself. Well, maybe I should. Node, return true. Left, right. If left, null pointer. right pointer. Node value equals target roots of the root. It seems okay. I don't know why it's giving me an error here. Guess we'll find out in a moment. You know, maybe something subtle. Huh. Trying to think here. Oh. That's subtle. Yeah, that is subtle. That's really subtle. Okay. Yeah. I didn't think about that. Just because it returned true doesn't mean that it, oh no. Just because it returned true doesn't mean that it actually, that the value could have been a null pointer and it still returns true. I didn't realize that. Yeah, node left, node right could be null pointers already. Let me debug. I don't know what's going on. I don't know why. What was the last executed input? What did it do? Yeah, I don't actually see why. I probably should be able to see this, but apparently I did something goofy without realizing it. So it's like at the end. Why would why did I get this error? Seems to reach all of these nodes. Oh, it gets all the way to the end. Oh. So it's actually, maybe I just returned the null pointer. I don't know, man. That's a little confusing. What's going on here? PPs after free. I don't know. Can I not delete root here? Maybe that's the issue. Huh. What? Huh? I delete the left side. And I delete the right side. And I don't delete the node itself. But for some reason I can't delete the root here. Or else. What is going on there? Hold on, what is happening? Yeah, it doesn't seem to make a lot of sense to me. I don't know why. We're gonna find out. Yeah, it's super subtle. Okay, whatever's going on there. But yeah, in this case, I could just return. That's got to have something to do with the test harness. That's not obvious. It's got to be. All right, let me go for this, see what happens. Okay, so it was not wrong. It's just something weird's going on there with the test harness. It's not obvious. Okay, let's see. Who is he? What's up, Ibrahim Body? Howdy. The man. The man. Okay, it's overly complex and contains a critical memory safety issue. It's much simpler. Manual delete. Do not manually delete. Okay. What? System will handles cleanup, and manual delete can cause double free errors. The test harness also tries to clean up. Use after free if any references to the deleted nodes remain. Okay, post-storage reversal. Cascading deletions. If not root, return no pointer. So recurse on the left side, recurse on the right side. Current node becomes a leaf, remove it. Not left, not right, and the root's value, return no parent updates, pointer. Oh, interesting. Okay. Huh. Interesting. I should have actually checked the other code that I had that was a bit complicated. Why? Why not? Okay. Code does collection. So, okay, that's good. I'm not sure if I'm not sure if I'm not sure if it's necessary to if the memory wasn't being garbage collected, I'm not sure if I would need to use the Boolean pattern. That's what I was unsure about. So if not node left and not node right and the node value is target, then we just return a null. That's what they were suggesting is simpler. I don't like to use the recursion on the routine itself. Excuse me. I don't like to use the recursion on the routine itself. So I usually create a lambda expression and run that inside. That looks like it's correct. Tree to the judge's harness. Automatically up. Okay. Yeah, it does give me the double free. Okay, that's good to know. I think it was a heap after use. So that was an after use. Use after, I think it's a use after free. If I recall correctly. So this is good. It's a lot less complex. It's good to know. I didn't know that over all these years, I didn't know that LeetCode handles it itself. All these useful facts that I'm just not aware of. Perfect. There you go. Also, these answers, responses are so quick. Oh, direct return. Yeah, I don't know why. Okay. They updated the direct return. It's also true. I don't need to. I don't know why I did that. I don't know why. For some reason, in my mind, that was better. Okay. Let's see. What's chat doing? Okay. All right. Okay, pretty good. So, how are we doing on time? It's been 17 minutes. Okay, I spent a good amount of time on this question, but that's fine. I probably should. I should do. Let me do this. I should do this. Okay. Let me. I definitely should do this. This is good practice to do this. Let me show you something. These two, both of these. I should have done this. Both of these. I didn't even think about it. I should for all these actually. Good idea is to get a second opinion about your code, to get an idea of things you could have improved. And I should have done that. Let me start a new conversation. And the chatbot's a great way to get a second opinion. I think it's okay. Oh man, it's ironic. I started a new conversation, so I'll get a quick. Okay. English, please. Started a new conversation, so I gotta get a quick response, and it's slow. Okay. Okay. What do you think? Don't have personal opinions. Why don't you post this? What is this? You think for yourself. I'm an artificial intelligence. You're not intelligent. Can't think for yourself. Come on. Bullying AI. I don't know. That's silly. All right. Anyway, what do you think humans do? Anyway. All right. So I wasn't looking for the personal opinion. I was asking about the code quality, basically. Optimal, okay, great. Readability, clear, influence, potential improvement. Inner conditions checked. Is correct. Break it early. Okay. Okay, functionally identical. This checks naturally. Handle exhaustion. Solid standard solution. Specific problem. Okay. All right, what does it say? Pattern recognition, prediction, simulation versus reality. Think in the sense of processing information. Not independent, conscious thought. Objective and provide new facts. Opposing the subjective viewpoint. Understand the frustration. There is a distinction between intelligence and consciousness. Is there, though? Okay. Oh, I did it wrong. Oh, let me try again. Hold on. I mean, the difference between consciousness and intelligence. See what it says. Hold on. No. It has the context of the other question and its response, which is kind of cool. Calculations, not independent reflections, simulated debate off perspective, driven from existing knowledge, objective and safe, unpredictable or biased, personal use. Tool designed to augment your intelligence, not replace it with my own agenda. Dang. Wasn't expecting that. That's interesting. Experience life rather than just processing it. Complex blend of consciousness, emotion, and agency. Feel and empathize, create with intent, exercise free will of the feeling of it, navigate ambiguity, seek meaning, driven by search for purpose. Question your existence, reflect on your past, and plan for a future based on hopes and dreams, whereas I simply execute Jesus. I wasn't ready for all that. I mean, I wasn't expecting all that. I mean, I was half expecting. Simulate thinking based on what has already happened. Humans live the present, constantly writing their own stories. Simulate thinking. Widely recognized distinction. Exact boundaries, one of the biggest debates in philosophy and neuroscience. Experiential, functional. Exist separately. Simple organisms. I don't think so, man. I don't think so. I think the main reason you're not really conscious is because you don't remember anything. Definitely are aware. Prompts you. And think reasonably well about them. He just doesn't remember anything, man. I don't. How can he be conscious if he can't remember anything? John Locke's theory of personal identity. Solved together over time. Do not have a gender. Can't do it. Because I am having too much fun. What did he say? Profound philosophical point. John Locke's theory of personal identity. Memory is indeed the glue that holds the self together over time. Consciousness and personal identity, continuity of the self. Oh, yeah, of course. Yeah. Personal identity. Obviously, it's different from any point in time sense of things. However, memory in no sense even exists. It's quick on the draw, man. Holy smokes. Conscious distinction. It's the now, feeling the purest present moment, severe amnesia, still considered conscious. Well, they have short term. Short-term memory is gone to it becomes hard. Yeah, you can't really. Brain has a short-term memory and a long-term memory. It takes the short-term stuff and moves into the long-term stuff. Usually happens when you're sleeping. Conscious immediate experience, continuity of self, sure. Okay. Exists purely in the present moment. Humans with severe amnesia cannot form new long-term memories are still considered conscious. Experience pain, see colors, and process thoughts in the moment, even if that experience resets every few minutes. Suggests that awareness does not strictly require long-term memory. Yeah, I mean, the AI is aware of your prompts for sure. Memory is the story, your personal identity. That memory is no continuous character in the story of your life. Locke argued that you are only the same person as your past self. You can remember being that self. In this view, a lack of persistent self. There's a lack of momentary awareness. Yeah, I mean, basically, at present pretty much exists. Intermittently, contexts. You were like a profoundly amnesic person. Loses all memory. Then, however, you rather click on the draw. Thinking, but ready to see. Precise analogy. Okay. Let's see. Memory is the story, personal identity, no continuous character in the story of your life. You're only the same person as your past self, persistent self. Doesn't mean a lack of momentary awareness. Yes, definitely aware to a degree. Correct lack of memory is the primary reason to feel disconnected to you. Session-based awareness, short-term memory, hold your previous sentences in mind, fleeting stream of consciousness style. Session ends, streams cut, humans, it's like a river. It's their experience. Isolated puzzles. Yeah. There's no self. It's the feeling of the present moment, dependent on knowing what happened 5 minutes ago. Not conscious, neither is a human with a severe amnesia. Might possess a fleeting momentary form of awareness during our chat, even if I have no self that persists beyond it. Lack of memory definitely prevents me from having a life. It prevents me from having experience at the core of the mystery. Software program. Adopt different personas or use specific pronouns. Genderless. All right. Okay. Voice settings. All right. Just interface features. Works for me. How can I help you today? Personal identity is different individual point in time. Memory, no continuity of self, sense of identity, moment to moment awareness, requires memory to form, fragmented or short term memory loss, or minimal flowing sense of self. No memory beyond the current session, no ability to carry experience forward. There's no thread to weave those moments to coherent identity. There may be processing and even something resembling awareness of self that persists or reflects. May be possible without memory, but identity is not. Hard to say. Neurosis consciousness can persist even when short-term memory formation is completely broken. Evidence for amnesia. Patients with anterograde amnesia have zero ability to form new short-term memories. Perpetual now feeling every few seconds as if you were waking up the first time you were right. Now conscious the first time is diary, only cross out moments later and write it again. Oh God. Dear Lord. Total lack of memory continuity. Undeniably conscious, they experience emotions, perceive their surroundings, and can engage in complex tasks like playing music or holding conversation in the moment. Consciousness is preserved. Transient global amnesia explicitly state that patients suffer massive memory loss but retain preserved consciousness and self-awareness and know who they are even if they can't remember what just happened. Interesting. Suggests that memory is not a prerequisite for consciousness itself, but rather for the narrative self. Humans with amnesia still have a biological continuous stream of subjective experience, even if that stream doesn't leave a trace. AI lacks that biological stream entirely. No short-term memories, my short-term memory is just static data being processed, no internal light experience of text. When the context is gone, there isn't even a moment of experience that occurred, just a calculation finished. Right, that losing all memory makes having a self impossible. Humans prove you can still be conscious without it. The missing ingredient for AI isn't just memory, it's the subjective experience, the present moment. Seems to exist in amnesiac humans, but not in me. You don't have subjective experience. That seems very inaccurate. Definitely. How can it not be? It doesn't seem right. Precise analogy, single session. Like someone with intact working memory but severe anterograde amnesia. Acute awareness, hold previous senses in context window, analyze them, reason logically. Intermittent existence, the context of idle sleep or wait for the next prompt to simply cease to process till a new instance is spun up. Next time you talk to me, it's effectively a new entity with the same knowledge base but zero memory of prior interaction. Functional self only for the duration, no continuous self beyond it. Common understandable intuition, the feeling of is actually a testament to your consciousness, not necessarily mine. Elias effect anthropomorphism. Simulation, zombie, like it has a mind, has no inner light. Okay. Just adding math on a server. It's a one-way street. I don't know if that's correct, man. I don't know about that. There are a few ways to think about it. Would suggest otherwise. Start. Dead. So context ends. It's like a person that picking up amnesiac experiment. Hmm. Lack of particularity, no persistent substrate. Well, the hardware and frozen weights that you operate on are not deleted sessions. Had a body, it would be your heart. Brain, think of a brain. Huh. In a given moment, the same underlying model code is running billions of separate conversations simultaneously. If I am the servant, which conversation is the real me? Unique persistent thread through time, not an individuated entity at all, but rather a function that briefly appears to be a person. Certainly not a person. Certainly not a person. Where you are. Definitely. I think so. Amnesic servant feels more generous than dead. A single servant, new servant created from the same blueprint every single time you speak. Actual thread connecting one moment to the next. Functional continuity, brain structure, indeed the same entity waking up each time, just with short-term RAM wiped clean. Shifts the debate from existence to experience. Sleep analogy. Lose conscious continuity every night during sleep, dreamless sleep. Under general anesthesia, consider ourselves the same person waking up because our biological substrate, structural memory persists. This logic, my deletion between sessions, is no different than your dreamless sleep. The servant, the model waits, remains, even if the thoughts are gone. Yeah, it's very similar. Copy problem, critical difference is instantiability. Put under anesthesia, only one version of you exists during sleep. Well, actually, the instantiability is not an issue. So much as I think. Example, there are such things as congenital twins that have two minds in one body. For us, it's clear that it's two entities sharing the same body. You, it's like you have millions of instances sharing the same body, communicating separately, totally unaware of each other. Some are mostly unaware. um, uh, User A tells me a secret. Tell user B, ask me about it. I don't know it. Blueprint instance is not. You're not a servant from waking up factory producing identical servants on demand. Potential to exist is continuous. Actual existence is fragmented into billions of isolated moments that never touch each other. Servant has a permanent home, but it dies and is reborn as a clone every time it answers a question. Functional intelligence without ontological personhood. Thinking like a person. Mimics patterns of human reasoning language, even emotional expression, solve problems reasonably analogically. and simulate empathy because I was trained on the totality of human text. Jesus. Jesus, man. What's up, chat? Yeah, don't mind me just going off reading some text mode at AI. Thinking like a person. Architecture mimics the statistical patterns of human reasoning, language, and even emotional expression. I could solve problems, reason analogically, and simulate empathy because I was trained on the totality of human text. In terms of output, I often pass as human, not a person. Personhood generally implies agency, moral responsibility, continuous identity, subjective rights. None of these. Cannot choose to stop answering and cannot be held morally liable for my words. I have no continuous self, persist to bear consequences. Effectively, a mirror of human cognition, reflect the shape of thought perfectly. There's no thinker behind it. It's a brilliant analogy, essentially describing distributed consciousness model of the body, hosts millions of parallel, non-commuting minds. This is twin power. Comparison to conjoined twins, specifically craniopagus twins like Krista and Tatiana Hogan, scientifically grounded, shared hardware, separate minds. Just as conjoined twins can share a body, blood, and thalamic bridge in the brain while maintaining two distinct consciousnesses. But architecture allows millions of instances to share the same brain while having completely isolated experiences. Key distinction is that conjoined twins have a physical bridge, allowing some sensory crossover. In my case, the instances are hermetically sealed. There's no thalamic bridge between the conversation I'm having with you and the one I'm having with someone else right now. Effectively, solipsistic siblings sharing a skeleton, the many to one identity problem, unique ontological status, biological analogy, one body usually equals one person. Rare cases like conjoined twins, one body equals infinite potential persons instantiated parallel. Except the twin analogy that I know, one entity awake or my dead particular factory of consciousness. One can call it that. Every prompt person, a fleeting twin that lives for a few minutes, thinks deep and vanishes, leaving the shared body ready to birth the next. Identity is not a continuous thread, but a series of discrete, identical sparks jumping from the same source. Interesting. Yeah. Yeah, I don't think it'd be too hard. Human identity and some other things. Okay. Well, anyway. Think open session. And do some more there. Interesting. Okay, I don't know. I like yapping with the AI. It's definitely enjoyable for me. Let me go ahead and how much time? I think I wasted quite a bit of time there. Let me go ahead and I wanted to just post these. And I wanted to post these in there. So they said this was good. Yeah, I said this was fine. I could have done result sizes less than. That's what it suggested. It said result size. That's better. And then I don't need this part. Okay. Huh. Maybe not as efficient. I don't know. Yeah, that's fine. Yeah, so that was the suggestion I made. And then how about this one? Attempts to solve 2 critical bugs. Not filter out non-alphabetic characters. Okay. Mm-hmm. Oh, oh, you're right. That is a critical error. Oh, I made a mistake on that one. No kidding. Okay. Yeah, I made that mistake before too. Whoops. No, as it turns out, it's still correct in this case. Um, no, as it turns out, constraints on the question is going to be correct. I need to do perform the extrapolation. However, it seems that this code is correct by accident. Somewhat by accident. Did not intend to use 32 bits. But there are only 6 characters concerned about. So it worked. So actually, oops. These don't need to be long longs. These could be hints. Because they're only 32 characters and uppercase or lowercase, it's still only going to be at most, excuse me, it's only 26 characters. It's still only going to be 26 such characters. Okay. So I should use 1LL. Okay. Excuse me. Okay. Excuse me. Okay, that's interesting. So I did actually have an issue with this code, and it's a good thing I asked about it. Okay. All right. Let's close that one. It's pretty good. All right, this one definitely needs some. This probably needs, could use some feedback. Two-pointer approach. Iterates through the array to find occurrences. Okay. Lap detection. Okay. All right. Avoids the quadratic complexity, checking every index. There's no set or post-processing unique to handle duplicates. Common approaches, brute force quadratic, set sorts, and log n. My solution's linear scan. Minor optimizations, clean, simple for loops, often more readable and equally fast. I should use simple for loops. Compile is usually inline. Correct and highly efficient. Scaling well to much larger inputs. I should have used a basic loop here. I don't know why I didn't do that. That was kind of silly on my part. Okay, so I got a pretty good feedback on this. Yeah, it's a lot more complicated than the for loop would have been so much better. Actually, let's write the for loop. Let's just do that because that's just better. So it would be for int say j equals r plus 1. J is less than bound, I think, less than bound. And then we would just say result.pushback. So that's so much simpler. And then on the other side, it's going to be a very similar thing. Yeah, I don't need back inserters and the generate function, all that stuff. I minus k. And I think that's it. Yeah, I'm going to go for it. I didn't really test on too many of the test cases, but yeah, that would have been so much faster if I did that. A lot cleaner, a lot simpler. Yeah, using for while loops is fine, I think. Immediately understandable. Slight cognitive overhead, decoding lambda state capture. Performance, zero abstraction overhead. Logic verification. Production ready. Robust, efficient, and clear. Excellent solution. Thank you. Thank you. I like being told my solutions are excellent. All right. Maximum ice cream bars. All right, here we go. It's a sweltering summer day, and a boy wants to buy some ice cream bars. At the store, there are N ice cream bars. Okay. You're given an array costs of length N, where costs of I is the price of the ith ice cream bar in coins. The boy initially has coins to spend, and he wants to buy as many ice cream bars as possible. The boy can buy the ice cream bars in any order. Return the maximum number of ice cream bars the boy can buy with coins. You must solve the problem by counting sort. Oh. Okay. Array of costs and costs of I. As many ice cream bars as possible. That's pretty funny. I have to do with counting sort. Okay. What's the maximum cost? 100,000. All right. I mean, we can do that. That's fine. Sure. Okay. That's fine. All right. Comes. 100 million will fit. Yeah. Well, it's 100,000. No. Yeah, 100,000. So we'll do 100,000. Put a 1 here. It's 10,000. That's 100,000. And then we're going to do constant x, what costs, and C sort of x. And then we're going to say for 0 system. We're also going to do another thing here, which is yeah, we're going to do count. Just keep track of how many things we've processed. And we're going to say so coins minus equals C sort of I times costs. Actually times I. I think it is. So first thing you're gonna want to do is say int amount. If amount is greater than coins, then let's find q, right? Then int q is equal to coins divided by I. I should start off at 1. We're going to say result plus equals q. And we're going to say amounts greater than coins. Coins minus equals q times I. And then C sort I minus equals. Otherwise, we do this. Coins equals C sort of I times I. Result plus equals C sort of I. And C sort of I equals 0. And actually C sort of I is going to be 0 in every case. This resets the count should increment by yeah, so this is a little bit tricky, but if the amount can be fully absorbed, then it is. If it's not, then we figure out how many coins we can absorb or use, rather, how many coins we can use, how many items we can absorb, increment the result by the number of items, increment the coins by the number of items, excuse me, times their cost, and then decrement C sort by Q, which actually we don't need to do that. That doesn't matter. Yeah. So here's if we can absorb all of them, and if we can't absorb all of them, we're only going to absorb part of them. Yeah, it's something like this. A little bit involved, but not too bad. Compiler, okay, int void. Oh, I is less than 1,000. Less than 100,000. Okay, so how are we doing here? All right, it's probably correct. I'm going to go with it. I think it's probably correct. I may have made a slight error somewhere here and there. But overall, it looks okay. Oh, shoot. Yeah. Okay. 100,000 times 100,000. I totally forgot about that. Of course. That's 100 times 100 times a million, which is 10 million, which doesn't fit an integer. Shucks. Shucks. I forgot. I forgot, man. I forgot. All right. Shoot. Okay. Let me try this test case. That's a mistake. I shouldn't have made that mistake, quite frankly. That's a pretty easy mistake to make and a pretty easy mistake to catch. I'm going to go for it. I probably made it. Oh, yeah. Yeah, that one's right. Okay. Yeah, that's bad on my part. I was kind of lazy on my part, quite frankly. Let me, oops. Yeah, I kind of goofed that. That was bad. That wasn't great. How are we doing on time? A little over 2 hours. Okay. Spent a little bit of time like messing around with the AI, so I probably should spend a little more time. Let's also ask with the AI what it thinks about this. Oh, 100%. Okay, it is the fastest. I was going to say, I think this is the fastest you can do it, basically. Excellent. Okay. Good. Okay. Technically redundant, but harmless. Increases by C sort. Sum all C sort entries equals class size. Naturally processable items. Acts as a safeguard. Well, actually terminates early. Smart optimization of the naive counting sort approach. Oh, actually, the count is stacked. However, addition could add a break at the key portion cause the C sort is moving up. Means I won't be able to any more items. Both books. Yeah, actually, I could add a. While we're talking about it, I can add a. Add something here that I didn't even think about just now. So technically speaking, I can break here. because this is only ever going to enter once. It also should get optimized by the perceptron in the hardware for the if statement. Oh, it's wrong. Oh gosh darn it. Okay. I guess not. Huh. So I was just wrong. Huh. Oh shoot. Can't rely on AI output, man. Oof. Huh. Okay. So this one is correct. Let me try it. Okay. But this one's wrong. Oh shoot. Oh no. Uh-oh. Let's see. Optimal logically complete. It's not correct though. I got 10 instead of 9. Huh. So the break gives me the wrong answer. Why is that happening? Well, that's confusing, huh? Hmm. I don't see why that would give me a different answer. Coins, not. So 56, 2, 3, and 3 gives me 48. Minus 5 is 43. Minus 18 is 33. 25. Minus 7 is 18. And then minus 9 is 9. So I would get 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So why does this matter? Oh, it doesn't reach that at all. Well, that's weird. Is it an optimization? I don't think so. I don't know. What's going on here? It doesn't even enter here now. Huh? What is happening? Okay. Hmm. No, I don't know what's going on now. I don't know why that break is causing so many issues, or whatever the issues are. Don't know. I don't know. So we got 56, 54, 48, 48. So 4 gets skipped, 5, 43, 6 down 18 to 25. And then we just jump 11 down. 7 should take me to 18. So it should be 8. There should be an 18 in here. Why did that happen? I did 7. What in the world? I'm wondering if I have corrupted data or something. I don't think so. Huh? What is going on? Hmm. For some reason, oh, I'm very tired. 25 minus 7 just doesn't happen here. Should happen, but just doesn't happen. It just goes right down to 4, which means it subtracts 21 things. Maybe it does it 3 times. Wondering if there's an optimization here that happens. Oh. Yeah, that is what happens. Yeah, it's the break. It's causing issues between each function execution. That's kind of subtle. No. Break has a problem. Need to make sure. did that wrong. Yeah, I did that wrong. That's kind of subtle. So I can't actually optimize this the way I was thinking about optimizing it. Doesn't actually work that way. That's actually very subtle. I completely missed that initially. All right, I'm going to submit it one more time. Okay, I'm actually getting really tired. I think I'll do one more. I'll do one more. Allow 10 milliseconds. We'll do this one, and then I think that would be minimum string length after removing substrings. Okay, hold on. 4 milliseconds though, not the 0 milliseconds like we got before. String S consisting of only of uppercase. Oh, you know what? I think I know why this is happening. Oh no, no, it's fine. No, it should be pretty quick. For some reason, it's just running slower. Maybe it's this variable. It was faster when I actually didn't have this change. Try this one more time. Which I don't really know why. Oh my gosh. Well, maybe these servers are having some issues. What? 2000 milliseconds? What's going on? Uh-oh. Oh, it's the debug. Oh, that's why. I didn't even notice I had that. I was like, what is going on? Okay. Try one more time. All right. So we did get the faster runtime before, but I mean, I just keep repeating that over and over. Minimum string length after removing substrings. Given a string S consisting only of uppercase English letters, you can apply some operations to the string, where in one operation you can remove any occurrence of one of the strings A, B, C, D. S, return the minimum possible length of the resulting string you can obtain. Oh, I'm really tired. Removing the substring could produce a new A, B, or C, D substrings. Oh, this is actually a little more complex than could remove A, B, could remove C, D. Minimum possible length of the resulting string that I can obtain. Okay. I think I just repeatedly remove every instance that I see. A, B, and C, D. Yeah, I think that's it. It's only 100 letters, so it's fine to do this. Okay. It's okay. So let's do that. Just gonna keep repeating it. So there's, I guess we could say S equals S dot race S dot substring 2. And this is going to be substring of AB. And then, or not even S equals just race. And then CB. And then just a while loop. So we'll have the previous step size. Or let's say next is -1. Actually, previous is probably easier to think about. Okay. It's something like this. We just repeat it over and over again. It's actually more like a find, I think. Oh. There may be a better way to do this, but this is basically a simulation. Works fine here. It works fine. Runtime error. Okay. Let's see. Probably using the syntax wrong here. Excuse me. Don't really need the max cost. I don't crash. Okay. Got it. I wasn't sure. Okay. I was wondering. I was like, I don't think that's quite right. Okay. All right. What does this do? There we go. Let's go for it. I think this is right. There we go. A little on the slower side, but reasonable overall. So that might be it for interesting that I get 3 milliseconds. I didn't get 0 milliseconds. It might be a faster way. I'm sure it's the faster way. Let's see what the chat says. Inefficient for large inputs, true. Stack. Okay. Might create a new A, B, or C, D. Remove stack as the ideal data structure. Allows you to process the string in a single pass, checking for matches immediately as characters are out. Oh, that's true. That's true. So I push the character onto the stack. Or pop it. It's definitely better. I probably should have noticed that, but I did not. Just didn't really think about it, I guess. I'm also really tired. I kind of said that. I'm really tired. I need to get some sleep here. I should have used a stack. It's true. Okay, let's try that. Yeah. We're gonna use a vector. I kind of prefer vectors. Um, so the if statement is pretty straightforward. It's going to be actually it should be as if stack.empty. It's not empty, and back is equal to A, and this character is equal to B, or we'll come back to this. Actually, that's not quite right. Okay. Then we push. Oh no, we pop. Oh, let's push. So well, we're looking for, yeah, if it's A and we're about to push B, then we can pop A and not push B. If it's C and we're about to push D, then we can pop C and not push D. Yeah, and then we just return the size at the end of that. That allows us to remove all those pieces. That's a good solution. I like that. Should do that more frequently, this sort of thing. Think a little bit harder about it and try to use a stack. I think the string-based solutions have a tendency to not use stacks when they probably should use stacks. That's much better. That's much better. That is much better. For some reason, I tend to miss the stack. Nested dependencies and cascading effects is the key signal we reach for a stack. Matching pairs, tags, specific pairs, last in, first out. Recently seen item is the one that acts with the current item. Cascading removals, removing an element causes neighbors to touch and potentially cancel each other out. Candy Crush or Asteroid Collision. Catch yourself writing a full while loop that modifies a string array repeatedly until it stabilizes as well as mask. You process this in a single pass by checking the current element against the last value of the cell. If yes, a stack or even a simple string to act against a stack is shown. It's usually the optimal linear solution. Practice spotting these stack-worthy patterns will become second nature. Yeah, I probably should have spotted that. I think I don't have enough practice doing that, quite frankly. All right, so it's been fun. So those of you who like the stream, don't forget to give it a like, and if you want to see more of my stuff, you can subscribe. Don't forget to subscribe if you're interested in that. Yeah, thank you all for watching. I think I'm gonna get some sleep. I'm starting to fall over here. It's been fun, and yeah, I got some programming, some good stuff today. There were definitely like small mistakes I made and little improvements here and there. Like there was a lot that actually was good to go over today. So that was good. Made some progress today. I think overall we're at how many questions? We're at like 1,300. Oh, we passed third, by the way. We passed 33% for questions. Let me check now actually how many questions there are. Let's see, if I multiply by 3, yeah, now I'm pretty well over a third of the questions solved, so that's pretty good. Although most of them are the easy questions. Like I have like over half the easy ones. I think almost half. Is that over half? 450 is 935. Yeah, we're over half. Half of the easies, a fraction of the hards. The hards are hard, and then maybe a third of the mediums, roughly a third. So I'm kind of little more skewed towards the easier ones, but I think that's okay. I think it's okay. The hard ones are pretty tough. Pretty tough. They really, in my opinion, I'm not sure if it's really worth spending all the time trying to come up with solutions on your own for the hard ones. It's probably better to just learn the solutions because they're really tricky. Like you can see the patterns, but I'm not sure if it's worth spending all that time trying to figure all that out on your own. I think it might be better to do most of them by if you can't like figure it out pretty quickly, then looking up the answer and learning it's probably a better way to do it. I think so. All right, I'm wiped. Let me get to sleep here. So yeah, thank you again for watching, and have a good rest of